Let's try to answer the following question. Imagine there is a checkpoint where a policeman measures the speeds of vehicles passing through. He notices that the distribution of these speeds follows a normal pattern. The mean speed is 61 kilometers per hour with a standard deviation of 4 kilometers per hour. Now, he wants to find out the probability that the next vehicle passing through the checkpoint will have a speed slower than 65 kilometers per hour. Pause this video for a moment and assume you are the policeman. Try to answer this question. Since we are sure that the speed distribution follows a normal distribution, we can calculate the z-score for 65 kilometers per hour in relation to the distribution by substituting mu as 61 and sigma as 4 into the z-score formula. The formula reveals an answer of 1 for the z-score. Because the requirement is to find any probable value less than 65 kilometers per hour in the first case, we need to find the area under the curve that represents values below 65 in the original normal distribution. Since we have standardized the normal distribution, it is more convenient if we simply find the area under the normal curve that includes all the values less than z-score of 1. Now, we need to realize that the z-score 1 in the standard normal distribution represents 65 kilometers per hour speed in a normal distribution that has a mean of 61 kilometers per hour and a standard deviation of 4 kilometers per hour. This would be true for any normal distribution with exactly the same mean and standard deviation. The whole point of standardizing the normal distribution is this. Instead of finding the area under the curve for many possible normal distributions, we can use the standardized distribution to find the area under the required value range. To achieve this, we use z-tables. To determine the area under the normal curve between the z-score of 1 and the mean, we go to the 1.0 row and the 0.00 column since our z-score in this case is 1. The row and column values intersect at the value 0.8413. This means that the area under the normal curve below the z-score of 1.0 is 0.8413. Therefore, the probability that the next vehicle passing through the checkpoint will have a speed slower than 65 kilometers per hour is 0.8413.